Hi guys, welcome back here at the EC Engineering tutorial. So this time, let's talk about water measurement. Okay, so this lecture is part sa irrigation engineering. Okay, so units of water measurement are considered in two classes. Number one is expressing it in specific volume of water at rest. So it could be liters, cubic meters, hectare centimeter, or hectometer. Or it could be expressing time rate of flow, no? So it could be liters per second, cubic meters per second, hectare centimeter per hour, or hectare meters per day. So these are the units used in water measurement. So the methods of water measurement are as follows. Number one is volumetric or volume methods of water measurement. Number two is using measuring structures such as orifice, weirs, and plumes. Number three is using the area velocity method or the float method. And number four is using the tracer methods. So for volumetric or volume methods of water measurement, so this method is suitable for measuring small irrigation stream, such as shown here. In this case, water is collected in a container of known volume. So, dapat alam mo kung ano yung volume ng container mo. And the time taken to fill the container is recorded. No? So, the rate of flow is measured by the formula. We have the discharge rate in liters per second is equivalent dun sa volume of water na naka-liters divided by the time required to fill it, no? In seconds. So, that's how easy the volumetric method is. So the second one is using the measuring structure. We have orifice, weirs, or plumes. No? So yung orifice is itong opening natin. No? So we call it orifice. May be used to measure the rate of flow when the size and shape of the orifice and head acting upon them are known. So provided meron tayong container dito, tsaka meron tayo ditong opening. So bali meron tayong head edge dito. So yan, no? Makikita natin dito na yung vena contracta is at distance d divided by 2 approximately, and meron siyang diameter approximately 0.61 of the area sa orifice natin. So itong makikita mo dito, itong tinatawag natin na vena contracta. So, free flow orifice. Orifice used in measurement of irrigation water are commonly circular or rectangular in shape and generally placed in a vertical surface, no? Such as shown here, no? So, andito siya sa vertical surface. Doon natin nilalagay yan. Perpendicular dun sa direction ng channel flow. So, the section where contraction of the jet is maximal is known as vena contracta. Okay, so the vena contracta of a circular orifice is about half the diameter of the orifice itself. So the basic physical law which determines the velocity of water through an orifice is the same law which determines the velocity of a falling body at any vertical distance below the point from which it begins to fall. So the theoretical velocity formula sa orifice natin is just square root nung 2 times the gravity times h, where yung v stands for velocity in centimeter per second, and g is the acceleration due to gravity, so it can be 981 centimeter per second, and yung h yan yung depth ng water or yung pressure head natin causing the discharge through an orifice in centimeter. So usually sa irrigation naka cm tayo. So experiment has shown that the actual discharge for a standard orifice is approximately 6/10 the theoretical discharge. Thus, Q is equal to 0.61 A square root of 2GH. Finally, the equation of the actual discharge is Q equals area times velocity, where area is pi d squared divided by 4 times velocity, which is coefficient of discharge times the theoretical velocity, which is square root of 2gh. So thus, yung Q natin is just pi d squared divided by 4 multiplied by the coefficient of discharge, CD, multiplied by square root of 2gh, which is the theoretical velocity. So, meron din, aside sa coefficient of discharge, meron din tayong tinatawag na coefficient of velocity. So, it is defined as the ratio of the actual velocity of a jet of liquid at vena contracta and the theoretical velocity of the jet. It is mathematically expressed as the ratio of CV equals actual velocity of the jet at vena contracta divided by the theoretical velocity, or CV is just velocity over 2 square root of 2gh. So owing with the frictional resistance, the actual velocity is somewhat less than the theoretical velocity. Okay? So less than talaga yan. No? Okay, so meron din tayong tinatawag na coefficient of contraction. So it is defined as the ratio of the area of the jet at the vena contracta to the orifice. So it is mathematically expressed as CC equals the area of jet at vena contracta divided by the area of the jet. And we have also coefficient of discharge, which is defined as the ratio of the actual discharge from an orifice to the theoretical discharge from the orifice. It is mathematically expressed as CD, that is Q actual divided by QTH, which is theoretical discharge. Okay? So, yung relationship ng coefficient of velocity, contraction, and discharge is shown here. No? CD is just the product of CV and CC. So, an example here, a 75 millimeter diameter orifice discharges 0.023 cubic meter per second of liquid under a head of 2.9 meters. No? The diameter of the jet at the vena contracta is found by calibrating to be 66.25 mm. Ngayon, ikakalculate natin yung coefficient of discharge, contraction, and velocity. So, bali yung figure natin, we have 75 mm nung diameter nung. Okay, so bali meron tayo ditong diameter na 75 mm. So, yung diameter ng vena contracta is 66.25 mm. And then meron tayo ditong head na 2.9 meter. Okay? So, that is measured from the center ng orifice natin. So, meron tayong formula for Q, which is A square root of 2GH. Like, given yung Q, anon yung CD, then, alam natin yung diameter ng orifice. So, meaning makukuha natin yung area ng orifice. And then, we have square root of 2 times 9.81 times yung head na 2.9. Thus, yung CD natin is 0.69. No? So, yung CC is just the area ng vena contracta divided by area ng orifice. So, we have 0.78. So, using the relationship between CD, CC, and CV, so we can now have the value of CV, which is 0.885 meters. No, dimensionless pala yan. 0.885 rather. Okay, so we have also submerged orifice, such as shown here. Makikita mo dito. Andito yung orifice mo. So may tubig ka dito, meaning nakasubmerge yung orifice mo. Okay? So you have this upstream water surface and downstream water surface. So the discharge of a standard submerged orifice is equal to 0.027 A square root of H, where Q is the discharge in liter per second, A is the area of the orifice, length times height, provided na ito yung orifice natin, no? Length times height, and then yung H is itong H dito is the head. So we have also fully submerged orifice. So bali, ito yung orifice mo, fully submerged siya, or it could be partially submerged orifice. So bali, ito yung orifice mo, makikita mo na partial, no? Yung other part niya is hindi nakasubmerged, no? Yung dito lang na part niya. So that we call it partially submerged orifice. So, in a fully submerged orifice, the outlet size is fully submerged under the liquid, and it discharges a jet of liquid into the liquid of the same kind. Okay, so it is also called totally drawn orifice. So the discharge through fully submerged orifice is calculated as follows. So we have Q that is equal to CD times B times H2 minus H1. So H2 and H1 are given, multiplied by square root of 2GH. Okay? So yung H1 is the height of water above the top of the orifice on the upstream side. Yung H2 is the height of water above the bottom of the orifice. And yung H is the difference in the water level. Makikita mo man dito. And then yung B is yung width ng orifice natin. So, in a partially submerged orifice, so in this case, its outlet size is partially submerged under liquid. So, the discharge through partially submerged orifice is calculated as follows, no? So, we have CD multiplied by B, H2 minus H1 times square root of 2GH plus 2/3 of CD times B times square root of 2GH times H2 raised to the power of 3 halves minus H1 raised to the power of 3 halves. So, makikita mo dito na mayroon tayong combination ng orifice tsaka dito is naka-weir, no? So, parang, kasi yung ito nag-act as weir, di ba? Then, dito is parang nag-act na orifice. So, anyway, yan yung formula na gagamitin natin for partially submerged orifice. So, let's have an example. So, find the discharge through a fully submerged orifice of with 2 meter if the difference of the water level on the both sides of the orifice is 50 meter. So, the height of water from the top and bottom of the orifice are 2.5 meter and 2.75 meter respectively. So, let's take the coefficient of discharge to be 0.6. So, bali, if we have if we list down the given, so bali yung width ng orifice is given 2 meters. Yung difference ng water level natin is again given. This must be cm, no? Apology for that. The height of the water from the top of the orifice is also given, and also from the bottom of the orifice is also given. Like using the formula which is shown nung una, ito yun, no? We just need to input all the given, like we can get the value of Q, which is 0.9396 cubic meter per second. So another example is water flows from a tank through 200 mm and 125 mm diameter orifice with a total drop in the water surface of 12.2 meter as shown in the figure. So the coefficient of the discharge sa dalawang orifice na to, makikita mo dalawang orifice, no? So meron silang CD na 0.65. Considering the flow to be uniform and neglecting the velocity of approach. So, ano daw yung H1, yung H2, tsaka yung maximum discharge dito. Okay? So to solve that, we have H1 plus H2 which is equal to 12.2, no? Makikita man natin yan dito sa figure, di ba? H1 plus H2 is equivalent to 12.2, no? And then, we know, kasi nakaano to eh, no? Di ba? By continuity equation, alam natin yung flow rate dito tsaka yung flow rate dito is the same, no? Let's say Q1 equals Q2, no? Or QA equals QB. So, we know the formula for the orifice is C area square root of 2GH. So, like, we just need to substitute the subscript for A and subscript for B here. So, like, cancel out yung coefficient ng discharge kasi the same lang man din. And then, maka-cancel out yung square root ng 2GH. I mean, yung square root ng 2G. So, bali yung matitira is yung area tsaka yung square root ng H. So, simplifying that, we can now get the value of, so, H2, that is equal to 2.56 square root of H1. So, yung H2 natin is 6.5536 H1. So, we know the H1 plus H2 is 12.2. We just need to substitute the value we get from H2 in function of H1. So, we can now have the value of H1. Diba? Okay? So, bali yung dito, nakikita mo, yung H2, yan yung HB ko dito sa equation, ha? Tsaka yung H1, yan yung HA ko sa equation. So, once makuha mo na yung value ng H1 tsaka H2, madali mo na lang makuha yung value ng flow rate, no? So, pili ka lang sa dalawa kasi pareho man din sila, no? So, bali yung discharge natin ngayon is 0.115 cubic meter per second. Okay, so we have also types ng orifice. Number one is submerged orifice with fixed dimensions. So these are used where the available head is insufficient for weirs, and for best result, they are usually rectangular with the horizontal dimension from 2 to 6 times the height, and the coefficient of this discharge will be 0.027. We have also adjustable submerged orifice. This is a combination of head gate or turnout and measuring device, and we have also calibrated commercial gates. No, these are the development of recent year, furnished with a design chart and table upon purchase. So parang may standard na siya, no, from manufacturer. Okay, so let's discuss this water flow measurement in the next video. Okay, so just keep on watching and keep on learning. See you in the next video. Thank you.